All right, welcome back. This is the Mole Vodcast number 5, composition, and this is Miss Carr. Today we're going to be talking about how we calculate the percent composition of a chemical formula. Now, this may sound very straightforward. For example, if you were asked a question like, what is the percent composition of H2O? What percentage of H2O is oxygen, for example? You might think that the answer is very simple, and that's that some people might say that water is 66% hydrogen and 33% oxygen because there are two hydrogens and one oxygen. Now, what this fails to address is the fact that hydrogen is a lot smaller than oxygen. So, oxygen is about 16 times the size of a hydrogen atom. So, if we actually look at the mass of these various elements, you're going to see that it's definitely not 66% hydrogen because hydrogen is itty bitty and oxygen is huge. So, we're going to look at the percent composition according to mass when we do these problems in chemistry. So while the 66% and 33% wouldn't be wrong if you were looking at the percent of atoms, if you're looking at the percent of weight or mass, then you are doing percent composition and it's going to be a little different. So the percent composition by mass in chemistry is actually incredibly simple once you know how to calculate the molar mass. If you don't remember how to calculate the molar mass, go back to vodcast number 2, watch it again, make sure that you know how to calculate the mass of a compound. This is the molar mass of the entire compound. So the percent composition is a very easy number to calculate, but you do need to know the how to set up the problem. And that is always the mass of the element that you are calculating. For example, if we said the percent composition would be, we'd be looking at hydrogen and then we'd look at oxygen. So the mass of the element, say hydrogen, over the mass of the compound, which would be water here. So we have the mass of the element divided by the mass of the compound. So the mass of one part over the mass of the whole times 100, of course, because it's a percent. That's what percent means, is per 100 pieces, right? So to show you an example of this with water, we're going to actually calculate the percent composition of water. Again, your percent composition is the mass of the element divided by the mass of the compound times 100. Okay. To find the molar mass of water first, which is the mass of the compound, so we're looking at this bottom part here, we have two hydrogens, and that is 2 times 1.008 or 1.0079, depending on which periodic table you're looking at. And so that's going to be a total mass of hydrogen is 2.0158 grams. Okay, and your one oxygen, of course, is 15.999 grams, and there is only one of those, so you don't have to multiply it times anything. And this gives you a total molar mass for water is 18.0148 grams because you add those two together, your two hydrogens and how much they weigh, and your one oxygen and how much it weighs, gives you the weight of 1 mole of water molecules. So we have the mass of the elements here and here, and we have the mass of the compound, which is our total here. So using those numbers, we can finish filling out our percent composition here because we have the mass of the element and then the mass of the compound on the bottom. So 2 divided by 18 roughly, and then we will multiply that by 100 and it will give us our percent compositions. Of course, we did the same thing down here with the oxygens. Remember, our total is the same for both elements because we're comparing it to water. So it's the percent of the water molecule. And that tells us that our water molecule is actually only 11.19% hydrogen, which means that it's 88.81% oxygen. And you'll notice those percentages are very different from the 66 and 33% that you would have expected had you not calculated the mass of each of the elements within the compound. So this is how you set up the percent composition and complete it. Now, percent composition is very easy to calculate. However, these questions can get a little more complex as we get more complicated formulas. We're looking at more complicated compounds. So as you get more and more atoms, it just makes a little more work. But the work doesn't get any harder. The work is just more. So we're going to do an example of one of those more complex questions. Now, if you would like, I would like for you to pause here and see if you can set up the percent composition for this formula. It is aluminum nitrate. So we have our aluminum, we have our nitrate, and there are 3 nitrates here. So I'd like for you to go ahead and pause it, give it a chance on your own, get a calculator, get your periodic table, get your notes, and see if you can set this problem up. And when you come back and unpause, we'll see if you got it right. Okay, now the first step to doing any of this is to, of course, write down your percent composition formula, mass of the element divided by the mass of the compound times 100. And then we want to find the mass of each of these substances, or each of these elements within the compound. So you have aluminum, if you check your periodic table, we have 1 times 26.982, which is, of course, your atomic mass for aluminum. Right? We can turn that into grams if we look at a mole of aluminum, for example. We have 26.982 grams. Then we have 3 nitrogens. Remember, this 3 on the outside of the parentheses will apply to everything within the parentheses. So this 3 applies to the nitrogen, giving us 3 nitrogens. We look up the atomic mass of nitrogen on the periodic table and find that it's 14.007. So we can multiply those out and we get 42.021 grams. And we have 9 oxygens. And if you're wondering where the hell did 9 oxygens come from, come up here and take a look. You see that we have our NO3 nitrate. Again, we have 3 nitrates. So if you have this oxygen 3 times 3 is going to give us 9 total oxygens. So that's 9 times 15.99, and that will give us a total of 143.991. As you can see, not only are oxygens are a pretty big atom, but we have lots of them in this formula. So even though the aluminum is a heavier atom, oxygen ends up taking most of the mass because it's large and there's lots of them. So we're going to take a look at how this compares to the total mass by adding all of our masses together. Will give us our molar mass for aluminum nitrate, and that will be the mass of the compound when we plug this into the problem. So since we already have all of the masses of the elements, we just divide each of these masses of the elements by the total mass of the compound. So we plug those all in to complete our formulas. And then, of course, we are calculating a percent, and so we need to multiply by 100 as well. So we have our mass of elements divided by the mass of the compounds times 100, and we can calculate each of those and get that we have 12.67% aluminum and 19.73% nitrogen and a whopping 67.6% oxygen. Now remember, for percentages, you do want to round these to 4 significant digits. So you want 2 decimal places for your percents. You should, and I encourage you to do this, if you want to double check your work and make sure that you had the right number of atoms of each and that you got all of your numbers in math correct, you can add these percentages together and they should give you 100%. Now, if they give you 99.99%, it doesn't mean you did something wrong. It just means that you might have a rounding error because you did round to the nearest 100th place. So, but adding those together should give you 100 or really close to it, and that will tell you that for sure you have the right percentages there. Okay? So that will be it for the Mole Vodcast number 5. So tune in for the next installment with Mole Vodcast number 6. And I will see you then. Please remember to bring this and all of your notes to class so that if you have any trouble or problems with this, you can let me know when you are working the worksheet for this particular lesson. Thank you very much. Bye bye.